Hello everyone, my name is Dr. S. Pavan Kumar Reddy, Department of Artificial Intelligence and Data Science, BVRIT, Narsapur campus. Ideal the subject is data structures using Python. Today we will discuss about the queues concept. This is the topics under the queues concept. What are the different topics are there? Here, first one is the basic definition of the queue. Definition. Next, what are the operations under the queue and how to represent the queues by using the arrays, and also linked list. And the next topic is how to implement the queues and operations on that arrays, and what are the applications in that queue, NQ, DQ and circular queue. This is the subtopics under the queues concept. First of all, what is the definition of the queue? Queue is a linear data structure. Queue is a linear data structure in which the insertions and deletion operations are performed in two different ends. In the queue data structures, adding and removing. Adding and removing means insert the elements and remove the elements are performed at two different positions. Actually, in this stack, we can insert the elements only like that. We can remove the elements from the same end. That means we can insert the element in the same end, delete the element from the stack in the same end. But the queues concept, we can insert the element in one end, we can delete the element from the another end. That is the queues concept. Here, the insertion can be performed one end and the deletion can be performed another end. The insertion operation is performed at the position which known as rear. The deletion operation is performed at the position which is called as front. Here, to insert the elements by using the rear, we can delete the element by front. Okay, that is the queues concept. Here, the insertion and deletion operations are performed based on the FIFO. What that FIFO means? First in, first out. Which element will be insert the first? That element only delete from the queue. That is the queues concept. See this example. This is the queue. The queue having the linear data structures. We can insert the elements in rear. We can delete the element from the queue. Here, actually these are the different general examples of the queues. This is the to purchase a ticket, either cinema theater or bus reservation counter. Which person will be first in that line? The person will be buy the ticket from the either theater or bus reservation counter. Another example is, this is the library management system. In that library, we can, the person have the standing in that line, the person having the either borrow the books or withdraw the books. Withdraw the books from the library. This is the another example. This is the person will be walking in that line order. The person will be entering into the line. The person will be removing the line. These are the general examples under the queues. Here, the queue data structure, the insertion operation can be performed by using the NQ. The insertion operation can be performed by using the NQ. The deletion operation can be performed by using the DQ. This is the simple general example of the queue. This is this front, this one is the rear. Both are the two operations. We can insert the element from the rear. we can delete the element from the friend. This is the simple example. See this example. The queues can be insert these elements. What are these different elements? 25, 30, 51, 60, 81. First element will be insert from this side. First element. Second element will be insert from this one. Third element will be insert this one. Fourth element will be insert this one. Fifth element will be insert this one. That means inserting the elements by using this side to remove the elements from this side. Okay, this is the general example of the queues. Here, see this one. This is the algorithms for the inserting the elements into the queue, deleting the elements from the queue. Now, see the one by one algorithm. First, you can solve this one. Here, rare equal to maximum minus 1. If rare equal to maximum minus 1 to display the overflow error. Otherwise, initially, the friend and rare both are initially minus 1 position. That means we are not inserting the any elements. That is, friend is rare, both are minus 1. That is this one. Now we can set friend equal to 0, rare equal to 0. The positions will be changed. Whenever inserting the element to by using the rare operation, it will be incrementing by 1. That means we can insert the element this one, we can insert the element this one, can insert the element this one, we can insert the element this like that. That means the rare equal to rare plus 1. That means every time whenever to insert the element to the queue, the rare will be incrementing by the 1. The position will be changed. Next, we can set the friend equal to 0, rare equal to 0. We can insert the element to the rare operation. The position will be changed from 0 to 1. Next time the value will be inserting to the queue. The position is changed from 1 to 2. Whenever we inserting the another element to the queue, the position is changed from 2 to 3. Like this. That is the rare equal to rare plus 1. Now, set queue of rare equal to item. If after the setting the friend equal to 0, rare equal to 0, we are inserting the element to the rare. That means the item will be inserting to the queue. Last step is exit. That is the inserting the element to the queue algorithm. Now we can see that deleting the element from the queue, how to step by step process will be there. First, initially start the algorithm. Now, if friend is greater than rare or friend equal to minus 1. Now, if friend equal to minus 1 means we are not inserting any elements to the queue. At that time, we are not inserting any elements to the queue. At that time, the output will be underflow error. That means there is no elements in that queue. There is no elements in that queue. We are performing the friend operation. It is not possible to deleting the elements from the queue. At that time, underflow error. Otherwise, if set item equal to queue of friend, if the item means data values, item equal to, is there any chance for deleting the elements from the queue? We are writing the item equal to queue of friend. At the time, set friend equal to friend plus 1. Every time we can perform the queue friend operation, the friend equal to, every time the friend equal to friend plus 1. Every time the value will be incrementing by the 1. Last one is exit that operation. This is the algorithms for inserting and deleting the operations from the queue. See that not only rare and friend operations, we are using some methods are also there. What are the different methods means? The operations are performed by on the Q data structure. First one is NQ of value. NQ of value means we are inserting the particular value. We are inserting the particular value. That is the NQ operation. Now, what is the DQ operation? DQ operation is deleting the element from the Q by using this method. We are not inserting any object. We are not inserting any object. That is the DQ operation. Next one is empty method. Is empty method means check whether the Q is empty element, the Q has any element or not. That means in the Q is there any elements or not. That purpose we are using the is empty method. Is empty method. Next one is full. Is full means it is used to check whether the Q is full or not. Whether the Q is full or not. Last one is display method. Why we are using display method means to display the elements of the Q. That is the Q operations. Here, the Q data structures can be implemented by using the two ways. First one is by using arrays and also linked list. Not only Qs, in the stacks are also implementing the by using arrays and also linked list. See the example of the Q operation. Initially, first we are creating the Q by using the Q equal to square bracket. Now, here Q will be created. Q is created. Okay? In that example. First, perform the NQ operation. What is the NQ operation means? We are inserting the elements into the Q by using append method. We are using append method. First element is A. Now, this is the friend, this is the rare. Rare means we are inserting the elements A, second element is B, third element is C. Initially, the Q having the friend equal to -1, rare equal to -1. That means we are not insert any values. The position of the friend and rare equal to -1. Okay, the position is 0, 1, 2. Okay, now we can perform the print the Q means we can print the values like A, B, C. Okay, now we can perform the peak method. Peak method means what is the top position in that element in that Q. Here front element equal to Q of 0. Top element, front element equal to Q of 0 means the 0th position element is the top position. Top position. That's why we are using the peak method. What is the peak method? In this example, the 0th position value is A. So, the peak method value is displayed. Now, we can perform the DQ operation. DQ operation means deleting the element from the Q. Deleting the element from the Q, the popped element, that's why we are using the popped method. Popped element equal to Q dot pop. So we are deleting the element from the friend. The friend side, the position of the 0 value is A. So the A value is deleted from the Q. That is the DQ equal to A. Next, now print the Q after DQ operation. To print the elements after the DQ operation means first we can delete the element A after the remaining elements are displayed B and C. Now we can perform the is empty method. Why we are using the is empty method means to check whether the Q is empty or not. The Q having the two elements B comma C element. So the Q is not empty. The Q is not empty. So the condition is false. The output value is false. Next, size. To print the size of the Q. So in the Q having the two elements are there, the size is 2. This is the simple example of Q operations. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.